Hang on, please. It should have it any second. There we go.
187030.
Thank you.
All right, ladies and gentlemen, this recording is to supplement the one that I provided you that apparently is showing some weakness. So I have here the recorded Excel sheet, as you can see at the bottom. And at the bottom, it has the difference of proportions and the difference of means, and let's see what else it says. And the difference of means and the differences of two means. So let me do the differences of two means with you real quickly. So I'll show you this one. And in this one, I have one that has computed data. So if you see, it has the 962, the 1033, and so on. And it has two of these. And so I am not going to send this to Excel. I'm just gonna literally put it in myself. So 962 and 1033 and 658 and 797 and 938 and 1074 and 1050 and 1099. Okay. So that's all the data for the in focus group, and Proxima is up here. So this is 961, 926, 850, 901, 594, 585, no, I'm sorry, 885, 1062, and 747, so 747. And what I want to do for both of these is the first thing I want is the average. And I want the standard deviation and the sample size. Now, sample size, you can see is 8 across, so it's gonna be 8 and 8. And an average, we're gonna go equals average and double click on an average and highlight all your numbers and hold. And do the same thing here. So equals average, double click, hold the numbers, and there you go. Standard deviation, STD, always equals first, STD. And I want .s, just the numbers, hold and drag. And if you want to cheat the system, just pull it over, it's the same thing. And so there are the averages, there are the means, and so on. Okay. So they want the difference of the two means. So in this case, let's see what, oh no, this is gonna go this way. Okay, we're going here. Nope. I see, we're here. Difference of proportions. No, I won't. Difference of two means. What is this one? This is a good one. We could use this one. So N1 is our first data set. And let me see if I can do it this way. Maybe I can see the. Okay, this should not be doing this. Let me delete this sheet. And this one I'm going to delete. I don't need it. I just created it right now by chance. And I'm gonna delete this one. So this is basically holding the data I need for the two standard deviations and the two means that I need. So I need these two numbers, 951 and 865. I need the 152.7, 141.9, and so on. So we're gonna take these numbers. I'm gonna control copy, and I'm gonna go ahead and go to the difference of means. I'm gonna just drop it here. Lovely. Let me not do that. So trying to do this with this. 951.375. Okay, so 951. Where's my X1? Here. So in this particular cell, I'm gonna put 951.375. And in this one, I'm gonna put the other number, which is 865.75. So this is 865.75. Sample size is 8. And this is already programmed, you don't have to do anything to this. The standard deviations, however, this has to be put in. This is 152.79 if we want. Let's do 152.789. And the second standard deviation we're gonna put is going to be 141.94. Let's go with 94. 141.94. 141.94. So that's all you need when you have the data that's given to you in that form. And this is the z-score. This is being the square root. So basically these two numbers, 85.625 and 73.7 are being divided. And that gives you this value. This is the p-value. So in this case, it's taking t dot dist. We're using the z-score, which is B14. We're using, let's see, we're using N1, which is C5, and we're saying true. This is supposed to be the degrees of freedom, so in this case, technically, it should be C5, which is what this is. And so basically, this is 16 minus 2. 16 minus 2 is 14. So this is the area below the t-value, which we got 1.16 and the 0.132. Okay. The second or the typical question you're going to have is going to look like this. So let's do this one. So an industrial plant wants to determine which two types of fuel, electric or gas, are more cost effective. And they give you the values. These samples consist of 12 using electricity. So let's say these 12 are electricity. And let's say that these 8 are the plant-based. Notice the value is 20 minus 2, 18. Here's degrees of freedom. The mean one is 71.99. So 71 7.99, and the second mean is 7.88. So the other thing you need is standard deviation. So the first standard deviation I gave you is 7.98. And the next standard deviation is 7.88. So now that you have that, you have exactly what the t-value should be. So in this case, I think this is 6180. I'm sorry, I apologize. This is 61.80. That's the two means. I give you 2.811. This is the area behind it. This is the area above it. So they ask for more than, that's the value. And these two are the critical values. This is a two-tailed test. All right, so that's that. The proportion questions, let's look at those. And so I'll do that after. This is the test of differences. Actually, we're gonna do the test of differences next. Let's do the difference of tests. The differences of means, basically. And so in this case, if you notice, I have 10 in this sample. I'm gonna make it so that we have 12. Let me see if I can insert shift, go down, and shift, insert, let's go roll down. So I'm tired. Okay, so this is so that these include 12 values. Notice that I'm going to put -59. I'm going to go here to the bottom at -59. So I'm going to go put this in. And 225. And 161. And here is -209. And -100. And -1015. -137. -271. And -35. And 58. -173. And lastly, 135. So this is how we explore these. Let's see what we're gonna do here. So we're gonna start with the mean, the average. Here's the standard deviation, and here's the sample size. Okay, so equals average. And hold and drag. Standard deviation, so equals STD. We're gonna do .s, so we'll double click. And hold and drag. And sample size is obviously 12. So this will be 11. So if you notice the test is right here, the test basically is gonna take A13 minus 0, which is gonna be 43, -43, divided by A14 by the square root of the sample size, which is 156.482, divided by the square root of 12, which is basically A15, which gives us -0.959. There's a two-tailed test, there's a critical value of one-tailed test, I take that back, one-tailed. So this is a critical value down here. This is of DV, D7, which is the value of negative 9.59, comma, and then D5. D5 is our value here, which is 11, degrees of freedom 11. So that value is that one, which gives us negative 2.718. This is being the critical value. I would go with, on this one, if we're gonna go critical value, this is T dot dist, not inverse. So I'm gonna erase this. And I'm gonna go equals T dot dist. And I'm gonna click on the value divided by the degrees of freedom divided by, or true, and that would be the area above, just below the negative 0.959, and the area above is going to equal 1 minus that 0.179, which is 0.821. So these are critical values here. So this is going to be the p-value. So I'm going to change this to p-value. And I'm going to do critical value down here, which looks at the alpha value. So in this case, the alpha value, let's see, what is the alpha value? 0.05, 0.01, what is this? 0.01. So 0.01, let's take a look. So critical value 0.01 is equal to T inverse, T dot inverse. Okay, T dot inverse, I'm gonna put in the Z score. I'm sorry, no, I'm not gonna put in the Z score. I'm gonna put in the 0.01. 0.01, comma, and degrees of freedom, which is gonna be 11 in this case. And hit enter, and that is the degrees of freedom. So this is the positive out, the negative of it. And if you want the positive of it, just use one of these. If it's greater than, it's gonna be the positive. Okay, so you have both the values there to use. The p-value, let's look at a p-value question. So I want to definitely give you one of those. And it's always going to be the case if p is less than alpha, we're going to reject a null. If p is greater than alpha, we're going to fail to reject a null. Okay. Difference of proportions. I have a sample question here. I can actually use this one instead. There's nothing different here. You use the values that are given to you. So in this case, you have 21 out of 100. Of the 100 people in the market category, 21 said that they would buy a subscription. And 33 out of 117 said they would not buy a subscription. Let me see, is this buy or not buy? They would buy, or of the 100 people in my market category who had been interviewed, 21 said they would buy a subscription, and of the 117, oh, in somebody else's market, 33 of the 117 said they would not. So look at the green. You see 21 and 100 are lined up, and 33 out of 117 are lined up. So what happens is there are some calculations that we're doing here. You see the negative 1.223 and the negative 2.326. So these are all values. This is a critical value here. This is the 2.36. And here's the z-score. Let me show you the formula. So it's B1 minus B2. B1 is 0.21. B2 is 0.28 minus 0 divided by the square root of B3, which is 249, times B4, which is the 0.75. This is P, this is 1 minus P, times B7, which is 0.1, plus B8, which is 0.0057. So this is a z-score, and this is negative 1.224. That came to 223. It's a calculation wise, the norm is inverse 0.01. That gives us 2.236. Can we conclude? Obviously, the answer is no. So if OV is greater than CV, we would reject a null. This would be OV. And you're looking at the absolute value of it. So OV greater than CV. This is obviously smaller. So if this is bigger than this, we're going to reject a null. This is not bigger than this, so we're going to fail to reject a null, so hence no is the answer. So that is a gist of the lesson. Everything is P less than alpha or OV greater than CV. In each case, you reject a null. I hope that you should be able to do the homework. Everything else is pretty steadfast. I wish you lots of luck. Let me know how you do.